Imagine a world where every digital lock is suddenly vulnerable. Quantum computers are poised to break current encryption methods, marking a seismic shift in cybersecurity. This video is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner and well-architect partner. We have certification distinction. We build and migrate workloads to Amazon Cloud. We are partners with Azure, Google Cloud, Databricks, Snowflake, Salesforce.com, TrendMicro, and Prevail. We specialize in data and analytics, AI&L, Gen AI, web and app development. Our AI offering is AI for You. Check out iforyou.cloud. We provide wide range of natural language processing or NLP services infused with Gen AI for language and document to offer multimodal capabilities. We have concept to code offering to translate ideas to products fast. See concept2code.ai. Our website is businesscompassllc.com. Our phone numbers are 973-638 and 2228. Our email address is contact@businesscompassllc.us. Q-Day is the term for when quantum computers render classical encryption obsolete. This day signifies the urgent need for quantum-resistant systems to protect our data. Quantum bits or qubits allow quantum computers to process information in parallel, unlike classical bits. This capability enables them to solve complex problems much faster. Shor's algorithm is a quantum breakthrough that can crack RSA and ECC encryption quickly. This poses a significant threat to current cryptographic systems. The exponential speed of quantum processing means tasks that took millennia can now be completed in hours. This advantage is a game changer for encryption. Experts predict Q-Day could occur between 2030 and 2040. While current quantum computers aren't yet powerful enough, rapid advancements suggest it's only a matter of time. Quantum computing progress is accelerating, with improvements in qubit stability and error correction. This rapid development could bring Q-Day sooner than expected. Q-Day will expose current encrypted communications, making them vulnerable. Industries like finance, healthcare, and government are at high risk of data breaches. The economic impact of Q-Day could reach trillions as organizations scramble to secure their systems. The cost of inaction is far greater than proactive measures. NIST is leading the charge in standardizing post-quantum algorithms. These new cryptographic methods are designed to withstand quantum attacks. Lattice-based cryptography is a promising approach, offering strong security against quantum threats. Starting the transition now is crucial for future safety. Begin by assessing your current cryptographic vulnerabilities. Understanding where your systems are weak is the first step in creating a quantum readiness strategy. Develop a migration strategy that includes hybrid approaches. Combining classical and quantum-resistant methods ensures a smoother transition. Transitioning to post-quantum cryptography involves performance trade-offs and larger key sizes. Balancing security with efficiency is a key challenge. Ensuring interoperability across different systems is crucial. Managing costs and planning budgets for upgrades are essential for a successful transition. Start planning your transition to post-quantum cryptography today. Testing new algorithms and building quantum-resistant systems is vital for future security. Organizations that act now will be secure when quantum computers arrive. By preparing early, you'll safeguard your data and maintain trust. Recap: we've explored the quantum threat, its impact, and the need for post-quantum cryptography. Transitioning now is crucial to protect against future vulnerabilities. By implementing quantum-resistant security, you'll ensure your organization's resilience against quantum threats, securing your digital future. Call to action: begin your post-quantum journey today. Assess your systems, test new algorithms, and build a secure future. Let's act now to stay ahead of the quantum curve.